If z is f of xy, where x is r cosine theta and y is r sine theta, the standard polar coordinate transformation, find z sub theta theta. Z theta theta, the second pure partial derivative with respect to theta. So we have z is a function of x and y, where x and y themselves are both functions of r and theta. And so we want to find first z sub theta, which is going to be z sub x times x sub theta plus z sub y times y sub theta by the chain rule. This is the chain rule. So z sub x times x sub theta is negative r sine theta. So this is negative r z sub x sine theta. We have z sub x times negative r sine theta. I'll put the z sub x here in the middle. And then we have plus, and we have to do z sub y times y sub theta. So z sub y times y sub theta. Y sub theta is r cosine theta. So we'll have r cosine theta times z sub y. So this is z sub theta. Z sub theta is negative r z sub x sine theta plus r z sub y cosine theta. So now we need to take the derivative of this again with respect to theta. So we need the derivative with respect to theta of z sub theta, and this is the derivative with respect to theta of negative r z sub x sine theta plus r z sub y cosine theta. Now, z sub x, just like z, is a function of x and y. So z sub x and z sub y both have this same variable tree. So z sub x is a function of theta indirectly, and sine theta is also obviously a function of theta, and therefore we're going to have to use the product rule here. So we're going to have to use the chain rule on z sub x, and we're going to have to use the product rule on the product. And the same exact thing happens here. This is a product of two functions of theta, so we need a product rule, and z sub y is a function of theta, and that requires the chain rule. So we're going to be using the chain rule within the product rule on this second derivative. So we have negative r, and then times, that's a constant with respect to theta, and now we have to do, we'll do the first, z sub x, times the derivative of the second, sine theta, plus the second, sine theta, times, and now we need the derivative with respect to theta of z sub x. And we'll calculate that in a moment. And then we have to do the same thing here. So it's going to be r times, I think I made a mistake here. This should be cosine x. I was supposed to take the derivative of sine. So this should be cosine. I left z sub x alone, times the derivative of sine, which is cosine, and then leave the sine alone, times the derivative of z sub x. So now, same thing here. I'll take the derivative of cosine, which is negative sine theta, leave the z sub y alone, and then plus cosine theta, leave that one alone, doing the product rule, and then times the partial derivative with respect to theta of z sub y. So the two derivatives that are left require the chain rule. So we have, I'll distribute here as well, negative r z sub x cosine theta minus r sine theta, and now times the derivative of z sub x with respect to theta. So we'll have to do z sub xx and then dx d theta, or partial derivative of x with respect to theta is negative r sine theta. And then plus, take the derivative of this with respect to y, that's z sub xy times the derivative of y with respect to theta, and that's r cosine theta. So that's this first piece now. That was the chain rule. And now we have plus the second piece. So we have plus, and then I'll distribute the r. So maybe that plus was a little premature here because we have negative sine theta. So we have minus r z sub y sine theta. And then we have plus r cosine theta. And now we have to do the partial derivative of z sub y with respect to theta using the chain rule. So we'll take the derivative of z sub y with respect to x, so that's z sub xy, times the derivative of x with respect to theta, and that's negative r sine theta, plus derivative of z with respect to y, so, sorry, derivative of z sub y with respect to y, so that's z sub y, times the derivative of y with respect to theta, which is r cosine theta. So this is our answer. We can clean it up a little bit. So let's see what we have here. Negative r z sub x cosine theta, and then we'll distribute here. So we have a plus r squared sine squared theta z sub xx, and then here we have minus r squared sine theta cosine theta z sub xy, and then we have minus r z sub y sine theta, and now we distribute again, so that's going to be a minus r squared, and then we have sine and cosine, sine theta cosine theta z sub xy. So that's exactly this term again. So there's two of these. And then we have plus r squared cosine squared theta z sub y. So we have the first order terms, which are negative r z sub x cosine theta minus r z sub y sine theta. And then we have the pure second order terms. So we have plus r squared z sub xx sine squared theta, and then plus r squared z sub y cosine squared theta. And then these two are identical, so we have minus two of those mixed partials, 2 r squared z sub xy sine theta cosine theta. 3, 4, 5 terms. So we have 5 terms altogether in our answer. If you calculate, so we just calculated z sub theta. If you calculate z sub r, it's a little bit simpler because since x is r cosine theta, when you take the derivative the first time with respect to r, you just get cosine theta and there's no more r's. But when you take the derivative with respect to theta, the variable theta will persist because the cosine and sine will just turn into the other one. So z sub theta is a little bit more complicated than the corresponding z sub r. Okay.